height will be increased, and you can observe that there is a thickness for the below object, and you can observe that the above one is 2-dimensional and the below one is 3-dimensional. See children, this is a triangle which is 2-dimensional shape, and below one is a prism which is a 3D shape. Children, when we want to represent these 3D shapes on a paper, that is called representation of 3D shape on a 2D plane, that you are going to learn in today's session children. Let us know the learning objectives. You will be able to know representation of 3D figures on 2D plane, polyhedron and non-polyhedron, faces, edges and vertices of 3D objects, prism and pyramid, net diagrams. Children, let us understand what is 1D, 2D and 3D figures. Take any 2 points and join them. Children, what you have to do? You take any 2 points and join them. You will get a line segment, right? So, a line segment is 1-dimensional, which is having only 1 dimension. Now, what you have to do children? Join line segments to form a closed figure. To get a 2D shape, we have to use line segments which are 1-dimensional. Children, here what I am doing is I am taking 3 line segments which are equal. I am joining them to make a closed figure. Children, this closed figure is a triangle which is a 2D shape. So, a triangle is formed by joining 3 line segments. How many line segments are needed children here? Yes, we need 3 line segments to form a triangle, and a triangle is a 2D figure. Children, when we join 2 points, we are getting a line segments which is 1-dimensional, and here a point is not having any dimension, but when you join 2 points, you will get a line segment which is 1-dimensional, and when we join these line segments, we will get a closed figure. Here we are getting a triangle which is a 2D figure. Now, what you have to do children? Take 2D figures and join them to form a 3D figure. Now, what I am doing children here? Yes, I am taking all plane figures. You can observe children here 1, 2, 3, 4, 5, 6. I am taking 6 plane figures which are 2D, means which are 2-dimensional. Now, what I am doing children? Yes, I am trying to move one by one so that it is forming a closed object. Now, the object which is formed is a 3D shape. So, here a 3D figure is formed by joining 6 plane figures. 6 plane figures are 2D figures. Children, before joining we have taken 6 plane figures, right? Those are 2D figures, but after joining you are getting a object which is a 3D figure. Representation of 3D figures on a 2D plane. Let us draw the following 3D figures on isometric dot sheet. Children, here I am taking a cube and combination of cubes. Now, what you have to do children? Yes, we have to draw them on a isometric dot sheet. Children, what is isometric dot sheet? An isometric dot sheet is a dots paper used to draw 3D objects with exact measurements. Now, I am taking the first object children here, right? This is the isometric dot sheet. Children, here you can observe that the 2 dots are separated with equal distance. These two, or these two separated with the equal distance, and this dots paper is called isometric dot sheet. Children, how to draw this cube on isometric dot sheet? See children, this cube is having 1 unit as the side. Okay. Now, what I am doing children? Yes, I am drawing a vertical line. Try to observe children here. I am drawing a vertical line. I am drawing another vertical line. I am drawing another vertical line. Total I have drawn 3 vertical lines children. Now, I am joining these 2 tops and these 2 bottoms. In the same way, tops, bottoms, I am joining children. Now, what I am doing? I am joining this to this and next this to this. So, I am getting the shape of this cube children. Now, let us understand how to draw the second one. Here we have 3 cubes children. Here 1 unit, 2 unit, 3 units. Height is 2 units children. Here the height is 1 unit. So, how to do this? Yes, first I am taking here diagonally 1 line, 2 lines, 3 lines. As it is 3 units children, I am taking here 3, right? Next, I am taking height 1, 1, 1, 1. First I want to draw this children, so I am taking 4 vertical lines. Okay. Now, what I am doing? I am taking the other dimension here 1, I am joining like this, I am joining the tops here, this tops. Next I am taking one more children, because a cube is there just above this, okay. So I am joining like this, next, and then what you have to do children, as we have this upside of this, we need one more cube which is just above that. So like this we have to do children. You can observe here 3 cubes are there at the bottom and 1 cube is there on the top. So total 4 cubes are there children here. Here also you can observe that there are 4 cubes. Like this we have to draw the given 3D shape on a isometric dot sheet. Children, let us draw a cuboid with measurements 5 units into 3 units into 2 units on a isometric dot sheet. Children, dimensions of cuboid are length 5 units, breadth 3 units, height 2 units. Now what you have to do children, as length is 5, we have to join 5 points. So starting 1, 2, 3, 4, 5. Starting, including starting, you have to take 6 points children. Next, the breadth is 3 units children. So if you want to include this, you have to take 4 points. If you want to exclude this, you have to take 3 points. 1, 2, 3. Okay, we have taken length, we have taken breadth. Now what is the height children? Yes, it is 2 units. So 2 units above, I am joining 2 points above. Here also 2 points above, here also 2 points above. Now we have to draw parallel line to this length, parallel line to this breadth, again parallel line to this breadth and parallel line to this length. Now we got the cuboid children whose length is 5 units, breadth is 3 units and height is 2 units. Children, like this you can draw a cube or a cuboid which is a 3D shape on a isometric dot sheet with given measurements. Children, let us understand what is top view, front view and side view of a 3D shape. Children, what you are observing on the screen, yes, we have 4 cubes. Children, if you want to see this from top, I have taken a separate color, that is orange color. From the side you can observe green color. From the front side you can observe violet color. Are you observing children? Here I have taken 3 different colors, one for top view, one for side view and one for front view. So top view only orange children here, side view green and front view violet. So like this you can understand how you can view a 3D figure. Now let us understand various geometrical solids. Children, here on the screen I am taking 5 solid figures. Children, what you are observing on the screen? Yes, various geometrical solids which we observe in our day-to-day life. Now let us understand what are called polyhedra children. Solid objects with all polygonal faces is called a polyhedra. Children, I am taking here examples, okay, cube, prism and pyramid. See children, this is cube, this is prism, this is a pyramid. All these are having only polygonal faces. We do not have any curved faces children. Here we have only polygonal faces. So let us understand the examples. Have you seen any time Rubik's cube children? Yes, it is a polyhedra. Dice, yes, it is also a polyhedra. Glass prism, yes, it is also a polyhedra. And Egypt pyramids children, yes, these are also polyhedra. Children, you are observing on the screen, right, different objects. Okay, so these all are polyhedra because these are the solid 3D shapes which are formed with only polygonal faces. Children, now you can see the names of the examples here. First one is Rubik's cube, second one dice, third one glass prism, fourth one pyramids. These are all examples for which one children? Yes, polyhedra, because these are 3D objects which are having only polygonal faces. Now let us understand what are non-polyhedra. Solid objects with curved surfaces are called non-polyhedra. Children, you can observe cylinder, cone, sphere. Can you give examples of non-polyhedra in our day-to-day life children? Yes, let us see some examples. Wooden log, birthday cap, ice cream cone, football. Children, first one is wooden log which is in cylindrical shape, second one birthday cap which is in cone shape, ice cream cone which is in cone shape, football which is in sphere shape. See children, these do not have only polygonal faces, these have curved surfaces. So we can call them as non-polyhedra. Children, on the screen you can observe a cylinder, cone, sphere and a hemisphere which are having curved surfaces. So what you have to call them, children? Yes, we have to call them as non-polyhedra. Children, now let us understand what is a prism. A solid object with two parallel and congruent polygonal faces and lateral faces as rectangles or parallelograms. Children, you can observe here three prisms. The first one is having the base as triangle, so we have to call them as triangular prism. The second one, base is square, so we have to call them as square prism. And the third one is having pentagon, so we have to call it as a pentagonal prism. Children, what is a pentagon? Yes, a polygon with 5 sides. So these are all prisms. See children, why we are calling them as prisms? Try to observe. This triangle and this triangle are congruent and they are parallel to each other. And remaining faces are rectangular or parallelograms. Try to observe children here. These two triangle faces are congruent to each other. They are parallel to each other. And remaining faces are either rectangular or parallelogram. Okay, here also you can observe square, this square are congruent to each other and parallel to each other. This pentagon and this pentagon are congruent and parallel to each other. Children, you can observe in my hands, right? What is this? Yes, this is a triangular prism. This is a triangular prism because the base is in the shape of triangle and the top surface is also a triangle. See children, these two triangular faces are congruent to each other and parallel, and these remaining faces are rectangles children. 1, 2, 3. These are rectangles. Children, what is there in my hands? It is a square prism. Okay, the base is in the shape of a square and the top surface is also a square and remaining faces are rectangles. Children, observe that remaining faces are rectangles. So this is a square prism. Children, what is there in my hands? Yes, a prism whose base is a pentagon because 5 sides are there children. 1, 2, 3, 4, 5. Total 5 sides are there. We are calling it as a pentagonal prism children. Pentagon, base and top surface is also a pentagon. Both are congruent and parallel to each other and remaining faces are rectangles. Okay children, now let us understand what is a pyramid. A solid object whose base is a polygon and its lateral faces are triangular faces. Children, here I am taking 3 pyramids. The first one is having triangle base, so we have to call it as triangular pyramid. Second one, square base, so we have to call it as square pyramid. Third one, pentagon base, so we have to call it as pentagonal pyramid. Children, what is there in my hands? Yes, it is a triangular pyramid. Why it is a triangular pyramid children? Because the base is in the shape of triangle and you have a vertex here at the top and the lateral faces are triangles. You can observe children, the lateral faces are triangles. Okay, total we have 4 faces, right? So the base is in the shape of triangle, so we are calling it as a triangular pyramid. Children, what is there in my hands? It is also a pyramid whose base is in the shape of a square. Okay, so it is called a square pyramid and you can observe that lateral faces are triangles children. In pyramid, the lateral faces are triangles. Okay children, what you are observing in my hand now? Yes, it is a pyramid whose base is a pentagon and we are calling it as a pentagonal pyramid. Children, here also you can observe that the lateral faces are triangles. Okay, so all pyramids are having lateral faces as triangles. Okay children, now let us understand what is a regular polyhedron. A polyhedron in which all faces are congruent, all edges are of equal length and all vertices are forming by equal number of edges. Children, here you can observe a cube, right? See children, here I am taking a cube. Here we will have 12 edges, 6 faces. Okay, all 6 faces must be congruent, means they should have same area, same shape and same size. Okay, and all 12 edges must be equal in length. Okay, then we can call a cube as a regular polyhedron. Children, here you can take a pyramid, right? This pyramid is having triangular base and remaining 3 triangular lateral faces must also be equal in area, so that we can call this triangular pyramid as a regular polyhedron. See children, triangular pyramid can be taken as tetrahedron. okay, because it is having 4 faces, okay. So a cube and a triangular pyramid are regular polyhedron. Children, now let us understand what is non-regular polyhedron. A polyhedron which is not a regular polyhedron is called a non-regular polyhedron. Children, what I am taking here? Yes, I am taking a cuboid and I am taking a square pyramid. See children, these are not regular polyhedrons. Why? Because in cuboid we will have 6 faces, but in that all 6 faces are not congruent, means they are not equal in area. Here also if you take square pyramid, you will have 5 faces, all 5 faces are not congruent. So we should not call them as regular polyhedrons. What we have to call children? Yes, these are non-regular polyhedrons. Now children, let us understand what is a cube. A cube is a regular polyhedron with 6 congruent faces, 12 equal edges, and all 8 vertices are formed by 3 edges. Children, you can observe I am taking a cube here. And you can see in our day-to-day life many examples for cube children, right? One is Rubik's cube, the other one is dice. Children, what is there in my hands? Yes, you are observing a cube, okay. So this cube is having total 6 faces children. This cube is having total 6 faces. All the 6 faces are congruent. You can observe on the screen children. These all 6 faces are congruent to each other. And you can observe the edges children where these 2 faces meet. This is one face. This is another face, right? Where this is meeting? Yes, at an edge. Like this we will have 12 edges children. All the 12 edges are equal in length, okay. That's why we are calling that a regular polyhedron, which is having 6 faces which are congruent, 12 edges which are having equal length, okay, and having 8 vertices. Okay children, now let us understand what is a cuboid. A cuboid is a non-regular polyhedron with 6 faces, 12 edges and 8 vertices. Children, you can see the cuboid diagram on the screen. Can you give examples for this children which we observe in our day-to-day life? Yes, a cotton box and a cake box. See children, here cotton box and cake box are in the shape of cuboid. Children, what is there in my hands? It is a cuboid. Children, is it a regular polyhedron? No. Why? You can observe. This is one face which is in square shape. This is another face which is rectangular in shape. Are these 2 congruent children? No, that's why it is a non-regular polyhedron. And you can observe this kinds of 3D shapes in our day-to-day life, okay, in more number children. Biscuit packets, okay, geometry box, duster, etc., etc. These are the examples which are in the shape of cuboid. How many edges are there children for this cuboid? Yes, we will have 12 edges, 1, 2, 3, 4, opposite 4, and here also total 4. So total will be 12 edges children. And how many faces children? Yes, 4 rectangular faces and 2 square faces. Total 6 faces children. So this cuboid is having 6 faces, 12 edges and 8 vertices. Okay children, now let us understand how to find faces, edges and vertices of 3D objects. I am taking cube here. First you should understand what is face children. Flat surface of 3D shape. Children, you are observing cube right here. This orange color surface, green color surface, violet color surface are called faces. Okay, these are called faces. Now, what is edge children? Yes, a line segment where 2 faces meet is called an edge. See children, here I am taking 2 edges. Orange color face and green color face are meeting at this edge. Violet color face and green color face are meeting at this edge. So these are called edges children. Now let us understand what is a vertex. A point where 2 or more line segments meet. See here, line segments are nothing but edges children. So here I am taking 2 points, we are calling them as vertices. Children, if it is 1 point, we have to call it as vertex. If it is more than 1 point, we have to call vertices. See children, here you can observe 2 line segments are meeting at this point. 3 line segments are meeting at this point, so we are calling them as vertices. Let us identify faces, edges and vertices of a 3D figure. Children, what I am taking here? Yes, I am taking a cuboid. Okay. Now what I am doing children? I am taking one plane surface out from the diagram so that you can count the number of plane surfaces children. How many faces are there children? Yes, we have 6 faces. And if you count the number of edges children, if you count the number of these line segments children, you will get 12. Okay, 3, 4, 5, 6, 7 and so on. If you count, you will get 12 children. So number of edges equal to 12. And where these edges are meeting, children? Yes, at points or vertices. So how many vertices are there for this cuboid, children? We will have total 8 vertices. So number of vertices equal to 8, children. So for a cuboid, number of faces equal to 6, number of edges equal to 12, number of vertices equal to 8. Let us identify faces, edges and vertices of 3D figures. Children, what is this one? Yes, it is a triangular prism. How many faces will be there for this, children? Yes, we will have 5 faces, 2 triangular faces and 3 rectangular faces, total 5. How many edges are there, children? Yes, we will have 3 plus 3, 6 plus 3, total 9 edges, children. And how many vertices will be there? Yes, 3 here, 3 here, total 6. So number of vertices will be equal to 6. I am taking the second one, a square pyramid. Can you tell me the number of faces, children, for square pyramid? Yes, we will have 1 base and lateral faces will be 4. So total 4 plus 1, 5. Number of edges, children, base you will have 4 edges and lateral surface if you consider you will have 4 edges. Total 4 plus 4, 8 edges, children. And number of vertices will be at the base 4, top vertex 1. So total 5, children. So like this you have to find faces, edges and vertices of a 3D figure. Euler's relation for polyhedra. If number of faces equal to f, number of vertices equal to v, number of edges equal to e, then f plus v equal to e plus 2. Children, this is the relation given by Euler. So we are calling this relation as Euler's relation for a polyhedra. Children, I am taking a pyramid here. Number of faces equal to 4, number of edges equal to 6, number of vertices equal to 4, children, for this triangular pyramid. Now what I am doing, children? Yes, I am finding first LHS. What is LHS, children, here? Yes, it is f plus v. So 4 plus 4 we have to take, children. What do you have to do, children? We have to take 4 plus 4, which is equal to 8. Now what is RHS, children? Yes, it is e plus 2. What is the number of edges, children? Yes, it is 6. So 6 plus 2, which is also equal to 8. Children, are we getting the same value in both the cases? Yes. Now can you say that Euler's relation is satisfied or not for this polyhedron? Yes, Euler's relation is satisfied. What is Euler's relation, children? Yes, it is f plus v equal to e plus 2. Let us verify Euler's relation for polyhedra. Children, I am taking a pentagonal prism. Number of faces equal to 7, number of edges equal to 15, number of vertices equal to 10. For this pentagonal prism, you can find number of faces as 7, number of edges 15, number of vertices 10, children. What you have to check? You have to check whether f plus v equal to e plus 2 or not. Children, what is f plus v? Yes, it is 7 plus 10, which is equal to 17. Children, what is e plus 2? Yes, it is 15 plus 2, which is also equal to 17. From this, what you can observe, children? F plus v equal to e plus 2. So Euler's relation is verified. Now I am taking the second one as pentagonal pyramid, children. For this, number of faces equal to 6, number of edges equal to 10, number of vertices equal to 6. You have to do the same, children. F plus v, 6 plus 6, which is equal to 12, e plus 2, which is equal to 10 plus 2, which is equal to 12. Children, are you getting the same here? Yes. So from this, what you can conclude, children? F plus v equal to e plus 2. E is a square prism and cube are same. Children, many students will get a doubt that E is a square prism and a cube are same or not. Now let us understand. All cubes are square prisms, but all square prisms are not cubes. Try to understand, children. All cubes are square prisms, but all square prisms are not cubes. Let us understand. Children, this is a cube. Okay. Now what I am doing? I am taking square prisms. This is a square prism, which is a cube. This is a square prism, which is a cuboid. This is a square prism, which is neither a cube nor a cuboid. Just we are calling it as a square prism. Children, what is the question here? Is a square prism and cube are same. Now these two are same, children, but these two are different. So from this, what we can conclude, children? All cubes are square prisms, but all square prisms are not cubes. Can a polyhedra have 3 triangular faces only? What is the answer, children? A polyhedra does not exist with only 3 triangular faces. Why, children? Let us understand. I am taking first triangular pyramid, second one square pyramid, third one pentagonal pyramid. See, children, the minimum number of triangular faces needed is 4 for getting triangular pyramid. For square pyramid, 4 triangular faces. For pentagonal pyramid, 5 triangular faces. See children, a polyhedra cannot form with only 3 triangular faces. Minimum number required is 4. Can polyhedra have 10 faces, 20 edges and 15 vertices? Let us check children. Euler's relation for polyhedra is f plus v equal to e plus 2. Number of faces equal to 10, number of edges equal to 20, number of vertices equal to 15. Children, what is f plus v? Yes, 10 plus 15 which is equal to 25. What is e plus 2? Yes, 20 plus 2 which is equal to 22. Children, here we are not getting equal. So, f plus v not equal to e plus 2. A polyhedra does not exist with 10 faces, 20 edges and 15 vertices. Now, let us understand what is a net diagram children. A net diagram is a skeleton outline in 2D which when folded gives a 3D shape. Children, what I am doing here? Yes, I am taking a triangle. Now, I am marking some dotted line here children. When you fold this with this line segments, what you will get children? Yes, you will get a triangular pyramid. So, for this triangular pyramid, this is a 3D shape children. This is called the net diagram. So, for this 3D shape, this is the net diagram. So, what is net diagram children? Yes, it is a skeleton outline which is in 2D. When folded gives you a 3D shape. Let us name the 3D shapes formed with the nets children. Okay, what shape you are going to get children when you fold this at the line segments? Yes, you will get a pentagonal pyramid. Now, observe the second one children. What you will get when you fold this? Yes, you will get a cylinder. Let us write the names of the objects given below. Children, this is the hexagonal prism. This is the pentagonal pyramid. How can you name this children? Very simple. Count the number of sides and you see that whether it is a prism or pyramid. As it is prism having 6 sides, we are to call it as hexagonal prism, and as it is pyramid because the vertex is there here and the base is a polygon, right? So, having 5 sides. So, we are calling it as a pentagonal pyramid. Children, try yourself. Draw a cuboid with measurements 6 units, 4 units, 2 units on a isometric dot sheet. Write the differences between a prism and a pyramid. Draw a polyhedron of your choice and verify Euler's relation for your polyhedron. Prepare net diagrams for cube and cuboid. In a polyhedron, if the number of faces is 6 and the number of vertices is 8, then find the number of edges. Children, try yourself to solve these problems and also try to solve some more problems from your textbook. For better understanding of the concepts, solve the worksheets, please visit the official website of SIET for worksheets. Okay children, in this session, we learnt about visualizing 3D objects in a 2D plane. Let us meet in our next session. Thank you.
अस्सलाम वालेकुम अज़ीज़ तलबा और तालिबात। आज हम जमात हश्तुम में समाज इल्म सबक नंबर 10 अंग्रेज़ों और निज़ामों के तहत ज़मींदार और लगानदार के बारे में हिस्सा दुव्वम में पढ़ेंगे। बच्चों, हमने देखा था कि रैयतवारी निज़ाम को थॉमस मुनरो ने 1800 ईस्वी में काश्तकारों के भले के लिए लेकर आया, जिसका मानना था कि काश्तकारों की हौसला अफजाई से ही काश्तकारी में इजाफा होगा, पैदावार में इजाफा होगा तो लगान में भी इजाफा होगा। तो उसने क्या किया, किसानों की हौसला अफजाई की, उन्हें कर्जे फराहम किए, औजार फराहम किए, अच्छी बीजें फराहम की। इसके अलावा तालाबों और जो कुएँ होते